Hello there everyone, my name is Gracie Caleb, and today we're going to be taking a look at some of these new variants called triangles. So these modules have been released since last year, but each of them there's currently 7 of them right now. Now today, we're only going to be taking a look at the first 4, and this is going to be based off of easiest to hardest. That's the way that we're going to do this. So today, we're going to be taking a look at clipping triangles, we're going to be taking a look at tipping triangles, we're going to be taking a look at flipping triangles, and we're going to be taking a look finally at slipping triangles. So far, these are the 4 easiest, and quite frankly, these ones are quite fun to do. It's not too bad, don't worry. So what's going to be happening here is that first things first, we need to figure out how we identify each of the individual triangles from one another, because each of their shapes are going to look exactly the same. However, the way that they appear on the module is going to look very, very different from each other. So since we're only going to be taking a look at these first 4 today, we're only going to focus on these 4 today as well. So let's take a look at clipping triangles first. This one is a pretty straightforward module to see. And what's going to be happening here is that we have a series of different triangles. So if all triangles are red, yellow, or blue and don't change color, this is going to be corresponding to tipping triangles. If any triangle alternates between 2 colors, this is going to be tripping triangles. If all triangles are either gray or off, this is going to be flipping. This is the one we're looking at right here. And by the way, this one was tipping right here as well. Then we have if all triangles are red, orange, or yellow. In this case, none of those are present here because each of them have blue, or they are simply flipping, which is gray or off. If all triangles are green, blue, or violet, in this case, this is going to be corresponding to slipping triangles right here. If all triangles are orange, green, and violet, this is going to be corresponding to skipping. Keep in mind that colors are very important in this because, as we can see, we have green and violet that both share in common on slipping and skipping. However, orange is the key difference here. Orange is what we're looking at. And finally, for clipping, if the highlight spans over multiple triangles, we're going to be doing clipping triangles. So now, what exactly does that mean? So if we happen to look at this module here, we can see that we can highlight each of these individual triangles. There's going to be 9 on the module total, with rows of 1, 3, and 5 of them, respectively. And in this case, if we take a look at this clipping triangle right here, we are able to highlight over more than one triangle space in this case. This is highlighting over 4 of them for the red. This is highlighting over 2 for the yellow. And this is highlighting over 3 for the blue. So this is going to be clipping triangles. And clipping triangles is definitely easier to see compared to the rest of them. The fact that it has, like, for example, this one big red over all of the rest, that means this is clipping triangles. So this is the way the clipping triangles works, and this is the easiest variant of them all. But the wording itself can be a tiny bit weird, which is why I'm going to be covering this stuff today. So let's take a look. So clipping triangles has in this case the same setup as any normal triangles do. And what's going to be happening here is that there's going to be a series of 3 different presses we need to perform, one with each color. And when we perform a press, what's going to happen here is it's going to be turning into a black space in that case. And that's going to be the same way for each of these triangles, including flipping, even though there is gray and black in this example. So let's take a look at another example here. So let's take a look at clipping. So now, what we're trying to do is we're trying to identify valid triangles. And what's going to be happening here is that we're going to find our first value by doing this sort of movement here. For each color, consider the color to the right of it. In this case, red considers yellow, yellow considers blue, and then blue considers red because it wraps around, and wrapping around if necessary, and check whether the first color is layered over the second color. And then let's take a look at this. So what we're going to do is we're going to check if red is currently layered over the yellow. In this example, red, this is the exact way that all of the triangles are going to be looking. However, we're only going to see the topmost layer. So in this case, the red triangle is actually at the top right here. And then the blue, in this case, is just barely underneath the red. In this case, the only spot where it's underneath the red is going to be at the topmost point of this triangle in this example here. And for the yellow is without question below both the blue and the red in this case. So this means that the red is going to be over the yellow. That makes sense. Okay, so the red is over the yellow. So that's going to be, I'm going to simply mark this as an O, for example. I'm going to mark this as O and U, for example, and you don't have to mark it this way at all. This actually could be a good solo for you guys, for those of you who know how to do this module. It's essentially going to be looking at red, yellow, blue. So red is currently over yellow. Now, we're going to take a look at the next one. Is yellow over blue? Is yellow layered over blue? In this case, yellow is definitely not layered over blue. And the way that we can tell this is because of the fact that, for example, the bottom right of the triangle in this example is going to be layered underneath the blue. here. So there would be up triangle, then down triangle in this example here. So let's take a look. So there would be up triangle and down triangle, which is represented where that yellow is right now, these two spaces. However, that bottom left corner of the blue in this where this red is currently right now, that is above the yellow in this case. So that means the yellow is not above the blue. So this means that this one is going to be under. Now, for blue, we need to check if that is layered over red now, because it's always going to be to the right for this first bit. Is blue over red? In this case, as we mentioned, no, it is not. The top part of blue is layered underneath the red, so that means red is going to be the topmost layer. And we have over, under, and under. That's the way that this model looks. So now, this process will produce three values, one of which will be different from the other two. And the pivot that produces the unique result is the valid color. And then what we're going to essentially do is, with this in mind, we're going to simply press this color, in this case, the odd one out. And here, the odd one out is going to be represented by the one that was over, which in this case we said was red. This was our over one. This was the only one that was over its color to the right of it, so this is going to be the first color that we press. And just like that, it disappears. No strike is given. If you happen to press an invalid triangle, it will immediately cause a strike. Keep that in mind. And this works for all of the modules here. Next up, then we need to consider the color that was pressed in order to get our second press. And then obviously, based off of process of elimination, our last press is going to be the last color that is remaining. Keep in mind that there's only going to be 3 presses for this entire thing right here, because of the fact that it is only 3 individual colors. And once we press one specific color, what we have happen is we essentially get rid of that entire color on the module here. So now what we need to do is consider the color that was pressed and check whether it was layered over its corresponding color. So all we simply need to do is we need to look at this chart here and check whether it was layered over its corresponding color. So the color that we pressed was red. Was red layered over the color to the right of it, in this case being yellow? It was indeed. It was the only color that was over everything else. So in this case, if it was, the next valid color will be the color to the right of the previously pressed color in the table. Otherwise, the next valid color will be to the color of the left of the previous color table. So in this case, what it's asking is was red over the yellow? In this case, it was. It was most certainly over it. So now what we're going to do is we're going to press the valid color that is going to be to the right of this. If it happens to be not true, it's going to be to the left. So in this case, our second color that we're going to press is the one to the right of red, which is yellow. And just like that, based off of our process of elimination, we now finally press the last unpressed triangle to submit this module and get it done. And just like that is a solved module. That's the first example right there done. It is quite an easy one to do, and it's not that hard at all. Next up, let's take a look at tipping. This module is also fairly simple. Let's keep this in mind. All of these guys are quite simple to do. In fact, the harder ones of this variant are definitely quite easier to do. However, the longer ones can take a little bit longer, I would say. So now let's take a look at tipping. Now, this one is much, much simpler, in my opinion, than the clipping triangles. It is a lot easier to do, and all we're simply going to be doing is we're going to be taking a look at this one here. So now, the difference between this one and the rest of the triangles, and the one that you want to distinct from very carefully, is going to be the tripping triangles. So now, all triangles are going to be red, yellow, and blue, and they do not change color. However, with tripping, this is going to be the case for what's happening with this module. If any triangle alternates between two colors, there is going to be the possibility of red, yellow, or blue on the module itself for tripping triangles. However, what's going to be happening is that every time on and off, there's going to be a series of 2 different changes. This module does not do that. So, and it's also just make sure that there's no clipping at all. In this case, the colors are completely spread apart, and we're only highlighting one individual triangle. This one is tipping. So now, we're going to be identifying valid triangles again. Simply makes sense. And to identify whether a triangle is valid or invalid, cross-reference its position in gray on the module with the color in the table below. And this will tell you whether or not the triangle is valid. And we're going to be pressing any valid triangle, and pressing a triangle that shares an edge with a previously pressed triangle is disallowed and will cause a strike, so don't do that. So now, we need to be careful with this one. A little bit trickier, but all we simply need to do is we simply need to essentially take a look at the position of which we're at in the module and correspond it with the color. And in this case, the red at the top, which is currently marked in gray, each position will be in one position, by the way. The red at the top is going to be an invalid triangle. We do not want to press this one. Next up, we have the blue over here. Blue is in this row right here. And this is going to be valid. So we're going to be pressing this guy right here. And now, what we're going to do is we're going to avoid the ones that share an edge. So we're going to be avoiding these two yellow triangles. So we're going to skip over this because we don't want to essentially press that, because it specifically says pressing a triangle that shared an edge with the previously pressed triangle is disallowed and will cause a strike. So don't do that. Very important to note down. And either way, if we happen to do the yellow, it would still be invalid in this position, so that's not going to work anyways. Next up, let's take a look at this red one over here in this position right here. Red is invalid over here, so now let's take a look down at this blue. This blue does not share an edge. It shares a corner, but it does not share an edge. That is one important thing to keep in mind. It does not share an edge. So this blue down in the bottom left here, let's take a look. This blue is down in the bottom left position. It's in one of these spots in gray. Blue is a valid position. So let's press this guy. Okay, that's good. So we're not quite done yet. So we need to find one of the presses in one of these last three spots right here. That's what we need to do. So we're going to skip over this yellow one because it shares both an edge with the red that we pressed. Or no, excuse me, it was the blue that we pressed from beforehand and the blue that we pressed down here as well. So now, let's take a look. So red is going to be down in this position. We cannot press that because of the fact that it is invalid. Red is now going to be down here. Red is currently valid in this position, as we can see here. Red is currently in this position. Makes sense on the gray. And red does correspond to a valid position. So we're going to be pressing this guy to solve the module. Just like that. Bada bing, bada boom. Next up, let's take a look at slipping triangles. Now, this one looks a little bit intimidating at first, but trust me, this one is really quite fun to do. I actually quite enjoy this one thoroughly a lot. So now, each triangle will be present in exactly two of the sets below, and this is referring to the position of which they will be present in. So for example, if we happen to take a look at this top tile, at the very topmost tile in this case, it will be present in this position right here, and this position as well. And now what we need to do is we need to take a look at each of the positions colors in this case, and see if they happen to both match each other's contents. So in this case, this first position is referring to the corners. In this case, that we get purple, purple, purple. And the second one is going to be a purple, green, blue. And our rule for valid triangles in this example here is valid triangles are those whose sets match in content, considering off as a color as well. Keep that in mind. So if we happen to press a position beforehand, that is going to have to be present in another sequence. That can possibly change some answers, but it is very rare for that to happen. So just keep that in mind. But if we take a look at these positions here, and these colors that are present in each of the positions that are represented in gray, these do not match content. So this means we're not going to be pressing this triangle. We have three purples here, but we have a purple, green, and blue. This does not match up. Okay, next up, we have green over here, this position. So we have this position that has an option here. And in these gray spots, we have green, purple, and blue. Now, one thing to note down, order doesn't matter. As long as the contents and colors are the exact same, that triangle is valid. So now, the other position for this guy the other shape for this guy right here is going to be right down here. Okay. And now what we need to note down is we need to note down these colors that are marked in gray. That's going to be a green, green, and purple. These do not match contents, so we're not going to be pressing this guy. We're not going to be pressing him. All right, next. Next, we have this guy right here. That's going to be in here and here, these two shapes. So now, let's take a look. So we have a purple, green, and blue for this first one, purple, green, blue. And we have a green, green, blue. Very close, but this purple and these other green do not match together, so this means that this is not valid. Now, next up, this purple here up in the middle right in this case, that is going to be in this shape and this shape. Okay. So we have a green, purple, and blue. Green, purple, blue. And then for this one, we have a purple, blue, purple. Not going to match. Next one. Next up, the purple down in the bottom left. And the bottom left is also going to include this one. Now, I can immediately tell the fact that there is a blue in the center of this one right here, and the fact that all four corners are going to be purple, this one is not valid. So we can just simply skip this one. Okay, we're going to be taking a look at this guy. So that's going to be in that position and this guy right here. Okay, So now, for this one, we have a green, blue, green. This is not going to match, I can already tell you that, because we have a purple, blue, and purple. This is a tricky one. This is actually rather quite unfortunate. So this is not going to match. Next up, we have the blue down here. So we have this blue in this bottom position. That's going to be represented right here. And then we have the this guy right here. So this guy is going to be a green, purple, and blue. Green, purple, and blue. And then the bottom is going to be a purple, green, blue. Now, if we take a look here, both of these contents, in this case, do match. So this means that this is going to be a valid triangle to press. And just like that is a solved module. So what we had here was we had to compare the two shapes and their respective positions. Now, the question was, did they have the exact same colors present in them and the exact same quantity of colors present in this position? And in this case, they both did. That is exactly what we needed to do for valid triangles, and this one is quite fun to do, especially when you happen to do it a little bit interactively. It's not that bad, trust me, and we'll go through one more example on a later VOD. So let's do that again. So now, let's take a look at our last one that we're going to be looking a look at today, flipping triangles. Now, this one is immediately distinct from the rest of them. It is gray and black, and that's all the colors that will appear on this. And this one actually is quite simple. So now we're going to pop out our handy dandy calculator for this one because we need to use our handy dandy calculator. So now let's take a look and let's see what we need to do. So we're going to start with 0, and for each triangle in order shown on the image in the top right, and in this case, the way that the order works for each of these, and it will always say that the order is going to be a 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. It will always be like this, and it essentially is in reading order. So we have 1, then 2, 3, 4, then 5, 6, 7, 8, 9. That's going to be the way that they work. And what we're going to do is we're going to go through each triangle in the image shown on the top right part of the page. We're going to double our number, and then we're going to add 1 if it's gray or 0 if it's off. And then we're going to finally repeat the sum. We're going to finally repeatedly sum the number of digits together to get a new number until it becomes a single digit. To sum up, what this wants us to do is after we're done going through all of these individual triangles, we're going to essentially perform the digital root, and the valid triangle is the one in that position in reading order, with the topmost being 1. So let's go through this. So we're going to start with 0, as we have right here. And now what we're going to do is for each triangle in the order shown in the image on the top right, we're going to double our number, and we're going to add 1 if it's gray, or 0 if it's off. So 0 is going to be first multiplied by 2, which is going to be nothing for this first one. It's off, so we're not going to be adding anything. Next up, we're going to multiply you by 2 again. Then now, since the second position has a gray in it, we're going to add 1 to this guy here. So now, we've added 1, and now we're going to move on to the next triangle. We're going to multiply you by 2. We're going to add 1 because it's gray. Now we're at the fourth position. We're going to multiply you by 2. We're going to add 1. It's going to be 7. Then what we're going to do is for these next few ones, we're going to multiply you by 2, multiply you by 2, multiply by 2, multiply by 2. So we're going to do that 4 times because we're not adding anything because it's off. These black ones refer to off, gray if it's on. So now let's multiply you by 4 times. So let's do times you by 2. 1, 2, 3, 4. And now let's do it one last time. But remember, we're going to add a 1 at the end of this. So multiply you by 2, adding 1. And now what we're essentially going to do is we're going to perform the digital root for this right here. So 225 was our total answer. So we're going to do 2 plus 2 plus 5. And in this case, our position that we're going to press with this module is going to be position 9. So let's hit position 9. And just like that is a solved module. Now, I believe that there can be more than one case. There can be some cases where you happen to have to do more than one press on that module. It can happen, but in this case, it didn't, thankfully. And it's just basically performing a little bit of binary, essentially. I like to call it. So now let's take a look at one more example for each of these modules. They are straightforward, but the wording itself can be sometimes a little bit wonky. So just keep that in mind, and I hope that this tutorial helps clear up any confusion that could happen. All right. And I will go through this a little bit faster. Hopefully I was able to cover all of this stuff consistently, and hopefully all of this makes sense, essentially. I would say probably the trickiest wording, per se, is going to be clipping triangles out of all of them. And it's important that you don't overthink it. It's a lot simpler than it actually seems.
There is only one perfect solution, but there are clues
So let's take a look at clipping. So we have clipping right here. And now let's check and see if the color to the right of each of these colors is going to be over or under it. So we have red is currently over yellow. That is true. So it's going to be over. Yellow is over blue. That is not true at all. And that's going to be under. And blue is over red. Yes, this one is indeed true because that bottom right portion is being covered up by this blue in this example here. So that is going to be an over. Now what we essentially want to do is we want to find the odd one out of this little set here. In this case, that's going to be corresponding to the one that is under, which is yellow. And we're going to hit yellow for our first color. That's good. So now, with this in mind, let's take a look. Then consider the color that was pressed and check whether it was layered over its corresponding color. Now, was yellow over its corresponding color? Was yellow over blue? In this case, we always go to the right. Was yellow over blue? No, it was not. It was not over blue. If it was, no, it was not. Otherwise, the next valid color is the color that will be the color of the left of the previously colored press color in the table. So now from yellow, we're going to go to the left and we're going to be pressing that color instead, which in this case is going to be red. And then we're going to hit blue to finish off, and just like that is a solved module. Let's take a look at the tipping. So now let's take a look. So we have red up in the topmost. That's invalid. We have blue in the in this middle left position. That is indeed valid. So we're going to be hitting that. Okay. Now we're going to ignore this red and we're going to ignore this yellow because of the fact that they are adjacent. They share an edge with that blue that we just pressed. So we're going to be going over to this position, in this case being red. That is invalid. We're going to ignore you. Next up, the bottom left position is going to be right over here, and it's blue. That is valid. Okay, that's good. We're going to be skipping that yellow from beforehand because it currently is sharing two edges, which is quite ironic. Then blue is going to be right over here. That isn't going to be valid, so we're going to hit this guy. Now we need to keep going, and from based off of our assumptions that we've already done here, we've already figured out that this, and this we cannot press these two based off of validity states, and these two based off of them sharing an edge, as well as this red right here, which means we cannot share this. We cannot have a we cannot press this one because it shares an edge with a previously pressed triangle in this case. So now, if we take a look at this last one based off of applied knowledge, this should be able to be pressed because of the fact that the module is not solved. So if we do the bottom right, in this case this guy right here, and blue, this is indeed valid. Bada bing, bada boom. So now, let's take a look at this last example here for slipping. Slipping, let's take a look. So green is up at the top. This one actually I don't think is going to have any sort of problems here. However, we could have well, it's going to be these two shapes right here. So they are going to be both have a green, but are the other two contents going to be the exact same? And immediately I can see that that's going to be a no, because of the fact that we have green, blue, blue, but we also have green, blue, and purple. It was very close to being the exact same, however, it was not. Now, one thing to keep in mind with this green is that if we happen to have any position that is the exact same as the one beforehand, or that shares a position, we're pretty much not going to be pressing this. It has to be specifically part of the. What I'm trying to say is that we've pretty much determined that we cannot press this position or any positions that associate with this one. Because of the fact that there's only one green, it basically makes it impossible for there to be any duplicate colors with this one. So let's take a look. So we have blue over here. We have in this position is going to be blue, purple, blue, purple, blue, and then we have blue, purple, purple. These do not match. Next up, we have blue pointing down. We've already determined that we cannot have this up in the upper position because if we take a look at this exact same position as this one, this is going to be right here. Green, I can already tell you is not present. Perfect. We're able to eliminate that option. Purple is going to be this position right here. That's going to be with this shape and that shape right there. So now, oh, here we go. So we have a blue, purple, and blue, and then we have a purple, blue, and blue. These two shapes match up. They both have the exact same content present in them. In this case, two blues and a purple, purple and two blues. This is going to be a valid position to press. And just like that is a solved module. Now, in most cases, you're going to have a one press with that one. However, I do believe that there is the possibility of there being more than one, as it says, considering off as a color as well. So we need to keep that in mind. Now, this is a lot of lucky examples, I will say, but now let's get into the fun mathy one. So now, we're going to multiply u by 2, and we're going to add 1, because it is a gray right now, so we're going to add 1 to u, because remember, we're starting with 0. Then we're going to multiply u by 2, and this second one is gray, so that's going to be adding 1. We're going to multiply u by 2. This one is currently black, so we're going to not add 1. Then we're going to multiply u by 2. Then we're going to add 1 to this, add 1 because it's a gray, plus 1. Then we're going to multiply u 1, 2, 3 times by 2, adding nothing to it. So multiply u by times 2, and times 2. And then we're going to multiply u by 2 again, and then we're going to add 1 because this is a gray, so adding 1. And then finally, we're going to multiply by 2 one last time. That last one is black. We're not going to add anything to it. We're going to do the digital root of this number here. So 4, 1, 8. 4 plus 1 plus 8. And then we have 1 plus a 3. That is going to give me a 4. We're going to press that position on the module, which is going to be right here. Now we need to do this again. This is where we have to go back and do the work again. Since that was an earlier press that we just did, that's going to change a lot of things up for us. So that's actually really important. And either way, it's just better off doing the actual work again. So let's take a look and let's see what we need to do here. So we have a 0 times u by 2, adding 1, times u by 2, adding 1. Then we have a times u by 2, times u by 2. Then we have a times u by 2, times u by 2, times u by 2. And then we're currently at this bottom tray right here. We're going to times u by 2 and adding 1. And then we're going to multiply u by 2 again. 386. Let's do the digital root of that. 3 plus 8 plus 6 is going to be a 1 plus 7. That's going to give me position 8. Position 8 on the module is going to be this gray right here. And just like that is a solved module. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I will see you guys in the next one. Bye-bye.